So let's suppose you had that x is greater than 6, let's say. All right? And in the problems we're going to look at, you're going to be asked to solve these inequalities. So you're going to find the solutions. Now, everything we've done so far were equations, right? Now, these are inequalities. So remember, your inequality symbols are greater than. This means what? Less than. This means greater than equal to, and this means less than equal to. So those are inequality symbols. So if I look at this inequality right here, how many numbers are greater than 6?
6 to infinity.
There's an infinite number though, right? There's not a finite number. Finite meaning that you can count them. That's an infinite number. You can't count them. So one of the things you're going to do is you're going to graph the solution. So since I can't list them like I can everything else, like today, you listed how many solutions? The one you just turned in? 2. You were able to list them. 3 and whatever the other one was. Here you can't list them because there's an infinite number. You have decimals, you have rational numbers, you have irrational numbers. That's part of your solutions. So there's an infinite number of those. So what you do instead is you graph them. So you can be given a number line. And so this is 0. Where is 6 located? To the right. All right, now here's the notation, and I got to make sure that I'm using the same notation as my math lab. Just, I think on my math lab, they use open and closed circles, I think, or maybe parentheses and brackets. Whichever one it is, I'll write it both ways, just so you know what to do for either case. So you don't see an equal sign, right? So that means that 6 is not a solution, because is 6 bigger than 6?
No.
No, 6 what? Equals 6. So since there's no equal sign, you're going to put an open circle on 6. So open circle means it's not part of your solution. And then I'm going to shade in every number that's to which side? To the right, because it says greater than. So that's how it looks. Okay? If my math lab uses parentheses or brackets, and I think that's what you used last semester was parentheses and brackets, this is what you would write. So it'd be parentheses, right? Open circle goes with parentheses. Closed circle goes with a bracket. So parentheses pointing which way, though? To the right. So it looks like this, going this way. So that's your graph. That's your graph. So notice that everything graphed is a solution. So how many solutions are there? An infinite number. Now, interval notation. Let's remind yourself how to write the interval notation. So interval notation, you read from left to right. From left to right. So where does my graph start? At what number? 6. Can it include 6? No. So you're going to say parentheses, 6 comma, all the way to what? Infinity. And infinity, remember, infinity you always use parentheses. Parentheses. All right. So that's your interval notation. What if you had this? X is less than or equal to, let's say, 4. So how many solutions are less than or equal to 4? An infinite number. Okay, so if you graph this, it, and I think my math lab uses the parentheses and brackets. I'm going to go ahead and use that. If I graph it, if this is 0, where's 4 located? On the right, right? Okay, now, is 4 a solution?
No. Well, yes.
Yes, because is 4 less than or equal to 4? Yes, it's equal to it. All right, so since there's an equal sign, I have to use a bracket pointing which way?
To the left.
To the left. Like this. Oops, make sure it's actually on the 4. pointing to the left, and then I shade in which area? To the left. Just like this. Now, when you write your interval notation, hold on, be careful.
Open parentheses.
All right, so when you write your interval notation, you read a graph from left to right. So notice that the arrow is pointing which way? To the left. So it's pointing towards infinity or negative infinity? Negative infinity. With infinity, negative infinity, you're always going to use parentheses regardless of whether there's an equal sign or not. So you're going to say parentheses, negative infinity, comma, 4 with a
Close
bracket. So that's what it looks like. Okay? All right. So tomorrow when we solve the linear inequalities, you do them the same way you would a linear equation, the same process. But one thing you got to be careful of is this. I want you to remind you about this. If I have 2x is less than, let's say, 8. Now, this was the easy kind. 2x is less than 8. If that was an equation, how would I get x by itself if this was an equation? Divide by 2. What's an inequality? You still do what? Divide by 2. And so I found the solutions. All my solutions are less than what?
Less than 4.
4, which is what this is. Okay? But what if you had this?
So even though that one says x is less than 4.
Oh, I'm sorry.
Yes.
Excuse me.
Yes,
No.
ma'am.
Without, yeah, thank you. Thank you.
I was thinking it, but I wasn't listening.
Yeah, so there's no equal sign, right? There's no equal sign. So the graph, this is 4, you can use parentheses or bracket.
Parentheses
So I'm taking this off. Pointing which way?
to the left.
Parentheses to the left. It'll be parentheses because there's no what?
4.
Equal sign. So is 4 a solution?
No.
No, because 4 is not less than 4. 4 is what? Equal to. And what will be your interval notation? Parentheses, negative infinity, comma what? 4 with a
With a curve.
parentheses. Just tell me parentheses. Don't say curve. Just tell me parentheses. All right? I mean, you never used that before. You always use brackets or parentheses. Now you use the word curve.
It's late. It's a long day.
All right. One more thing, and then remember how to do this one? Negative 3x is greater than or equal to, let's say, 6. That's the one you had to be careful about. So you may remember this idea. To get x by itself, remember I'm solving an inequality, right? To get x by itself, I have to do what to both sides? Divide by a negative 3. Now, one of the things you learned was that if you divide or multiply an inequality by a negative number, you have to reverse the inequality symbol. So what happened, if you recall what I did in that course, was I circled this to remind me to do what? To reverse it. So negative 3 divided by negative 3 is 1. 1 times x is x. But x is not greater than or equal to. X is what? Less than or equal to a
3.
6 divided by negative 3 is negative 2. And now what does the graph look like? Here's 0. Here's negative 2. Parentheses or brackets. Bracket pointing which way? To the left. So I shade in all this. That's your graph. What's the interval notation? Parentheses,
Negative infinity.
comma,
Negative 2.
negative 2 with a
Bracket.
bracket. Okay? So that was the basic thing I need for you to be able to remember in order to do tomorrow. Now, do you remember why you had to reverse? What we did when we first started talking about this in that course, it was 2 semesters ago in that course, suppose I had this. Suppose I told you that 8 is less than 10. Is that a true or false statement? That's a true statement, right? 8 is less than 10. Remember, what you do to one side, you do to the other, correct? So if I divide both sides by 2, is that inequality symbol still correct? Yes, the inequality symbol is still correct. 4 is less than 5. That's still a true statement. So notice here, when I divided by 2, did I reverse the inequality symbol? No, because I was dividing by what kind of number? Positive. But if I divide by negative 2,
Changing the,
all right, I'm not going to put the inequality just yet. If I divide by negative 2, what's 8 divided by negative 2? What's 10 divided by negative 2?
-5.
Is negative 4 less than negative 5 or greater than negative 5? Greater than. So you had to go from less than to what? Greater than. All right. So that's what we did when we first tried to understand, well, why is it that I've got to reverse? Well, use a simple example like this, and you can see why you need to. So the idea was when you divide and multiply an inequality by a negative number, you have to reverse. So we do the examples tomorrow. There'll be some examples where you are going to divide by a negative number. You just got to remember to reverse the inequality symbol. Okay? All right.